In this video, we'll be talking about multi-agent systems. To understand what a multi-agent system is, we will cover the main fundamental concepts involved. We will be talking about agents, agent architectures, multi-agent systems, environments, communication, and coordination. Let's start at the beginning. At its core, a multi-agent system is a system involving multiple agents. For that reason, we need to start with defining what an agent is. The definition I'll be using here is that an agent is a computer system that is situated in some environment and that is capable of autonomous action in this environment in order to achieve its delegated objectives. So let's break that down. To begin with, in this definition, an agent is a computer system. Sometimes the term agent can be used to describe anyone for who this definition holds, and that means that people can also be agents. In this case, we often use the term artificial agents to refer to agents which are computer systems. The second important part is the environment. An agent exists in some form of surroundings, which means that it can observe the things that happen around it. This can be very simple input or more complex observation skills. Then, an agent is capable of autonomous action in this environment. That means that the agent has some form of decision process to decide on a given action. Autonomy is difficult to define, but at its core here, it means that no human or other systems are necessary for the agent to decide something. It also means the agent can perform actions which in some form or way influence the environment, as these actions are meant to achieve some goals in that environment. Let's give some examples of very simple agents. One would be your thermostat. This thermostat exists in an environment, probably a room, and it can observe something about its environment, namely the temperature. Based on this observation, it can perform actions to turn the heating up or down in order to achieve the goal of having a certain temperature in the room. Another example of a simple agent is a background process of your operating system, which monitors incoming emails. Such an agent exists in a digital environment where it observes when a new email comes in and can send out a pop-up message if there's any unread emails. Both of these examples are very simple agents. Most people would not call these intelligent agents, and often in multi-agent systems, the goal is for the agents to be a bit smarter. For intelligent agents, there are a couple of extra things which are typically expected. The first is proactiveness. We expect intelligent agents to take the initiative to satisfy the goals that they have. The second is reactivity. This means that intelligent agents are able to respond to changes in the environment with proper timing to achieve their goals. And the third is social ability. Intelligent agents are able to interact with other agents in their environment to achieve their goals. In multi-agent systems in particular, this third ability to communicate and coordinate with other agents is a key defining factor. Agents need to be able to make decisions, and to do this there's a number of different approaches which we call architectures. 4 of the main types of architectures for agents are logic-based, reactive, belief, desire, intention, and layered architectures. The first 2 types of architectures globally correspond with 2 of the main approaches in AI, namely symbolic and subsymbolic. Logic-based architectures are symbolic, and they rely on logical formula to govern the behavior of agents. At its core, these logical formula define predicates which describe facts, and rules which describe what to do when what facts hold. Reactive approaches at their core deny this symbolic approach, and one example would be the use of Markov models. These model stochastic processes and Markov decision processes, or MDPs, are aimed at finding policies for behavior that maximize some reward. Belief, desire, intention, or BDI architectures try to model practical reasoning. The main concept is that an agent has a set of beliefs, desires, and intentions on which its actions are based. Beliefs are notions about the environment, for instance that it's currently 20 degrees. Desires are goals for the environment, for instance that it should be 22 degrees. And intentions describe the intended actions, for instance to turn up the heat. A BDI agent could then have a function which describes that if the desired temperature is lower than the goal temperature, the intention to turn up the heat should be adopted. Finally, layered architectures describe the type of architecture where the different subsystems exist to deal with different behaviors. Horizontally layered architectures have different layers which each control the full decision process from input to output. For instance, an agent which can turn down the blinds based on the amount of sunlight and turn up the heat based on the temperature. A vertically layered architecture is a system where sensory input and action output are dealt with by one layer each. We've talked about agents, which are the main components of a multi-agent system. Very basically, a multi-agent system is a system with several agents. To be a bit more precise, a multi-agent system always needs to have an environment which is shared by the agents which exist in it. Two agents which have disjoint environments would not really be considered a multi-agent system. Additionally, most multi-agent systems are characterized by a certain level of communication and coordination between agents. This means that there is a way for agents to communicate with other agents in the same environment. They might not be able to always communicate everything to everyone, but in general, agents can convey information to each other. And communications could be about observations in the environment, but also about anything else which the agent knows or thinks in some way. Finally, coordination plays a large role in multi-agent systems. Coordinations are those mechanisms with which agents can align decisions or make decisions as a group. And they can be simple, such as a vote to make a collective decision, but often get a lot more complex as well. To conclude, this video introduced the concept of an agent and multi-agent systems. We've looked at the definition of an agent and an intelligent agent, and we've seen the most common agent architectures. And we have seen what the most important characteristics of a multi-agent system are.